Good morning to all. This is Akanksha Shukla from Information Technology Department, and today I am going to discuss one of the most important topic which is related to data analytics, and also we can say that it is a part of machine learning algorithm. The topic is association rule mining. So basically, what is association rule mining? So it is a kind of just unsupervised learning algorithm, or we can say that it is an unsupervised learning technique which is used in market basket analysis or which is used in business analysis, basically to identify the shopping patterns or to identify the item sets which are associated with each other or which are correlated with each other. So also it is known as market basket analysis and helps in finding the interesting relationship between the variables, items, or we can say that different kinds of events. So it in terms can also help in cross sell related items, and which in turns the increases the size of the sale. All the data which is used in this technique is categorical data. There will be no any kind of dependent variable which is used in this kind of technique. It is a kind of machine learning algorithm. So it uses the concept of machine learning algorithms also. And in this technique, it accepts the input as a raw data in terms of sale transactional data. Means in terms of market basket data, it takes that kind of data as an input, and then the output produced, whatever the output is produced based on that particular input, which is a kind of transactional sales transactional data. So the output produced is the description of the most frequent affinities or the most frequent item sets among those given data sets or items. So the example of association rule can be a customer who bought a laptop, computer and virus protection software. He or she might be also bought an extended service plan 70% of the time. The another example which is most frequently we can see in our daily life, that is the customer who bought bread and milk, he or she can also bought a butter 80% of the time. So the data items or these events or the items bread, milk and butter, these items are correlated or associated with each other, that most of the time most frequently we can see that the customer who is going to buy a bread or milk, he or she will also buy a butter 80% of the time. So these kind of relations or these kind of associations we can easily mapped or we can easily identified by using the association rule mining concept. Now, what are the different or business applications of the association rules? So in business environments, the patterns or the knowledges can be used for different kind of purposes. Just like in sales or marketing department, it is used for e-commerce site designing, online advertising optimization, the product pricing, sales, promotion, configurations. Different perspectives can be used in sales or marketing. So this analysis can just suggest not to only put one item on a sale at a time, instead of creating a bundle of products which are promoted as a package to be sell other than non-selling items. Means if in a market basket analysis or if in a market or business environment, if we can see that some of the items are not selling at a particular point of time, so we can with the use of association rule mining, we can make up packages of using the different kinds of products which are not be sold by the current sellers. So we can make a package of that particular kind of items, and based on that bundle of products which are promoted as a package to sell, the sale price of the items can be promoted or can be enhanced. In just the retail environments also, it can be used for storing designing or store designs. Strongly associated items can be kept close together for customer convenience, so that the customer can buy the items which he or she can be frequently opted by themselves, or they could be placed far from each other, so that the customer has to walk the aisles, and by doing so is potentially exposed to other items. So different techniques can be used or can be applied by the business environments, that if for the customer convenience, you can also kept the items which are frequently brought together. So you are going to kept that items in a particular package form or at a one place, so that the customer can easily opt all the items which he or she is going to opt. The second technique is also preferred, that the items can be placed far from each other, so that the customer has to walk from one item to another, and also he or she can explore much more for the much more about the different items also which are placed between from one item to another item. So he or she can also expose to other items also by doing this kind of technique. Now, to represent the associations rule, the generic rule is represented between a set X and Y is X tends to Y, and S percentage and C percentage, whereas S denotes the support and C denotes the confidence. X and Y are the products or the services which is going to be provided, and X is LHS, Y is RHS, left hand side, and right hand side, and S is the support. The definition of support is how often X and Y, both the item sets or both the products, how oftenly these two items are going to be used together in the total transactional data can be termed as a support. And the confidence defines how often Y goes together with the product X, means how oftenly the two products are going to be goes together, are going to be consumed or sold together by the customer. So that will be denoted by the confidence C, and the support is going to be identified, or it simply identifies that how oftenly X and Y, different item sets, whatever the item sets are given in a total transactional data set, then how many times a particular event or a particular data is occurring in a total transactional data set is defined by the support S. So, for example, there are 100 transactions. There are 100 transactions, and out of 100 product X was bought 80 times, and product X and Y were bought 60 times. Means individual product X was bought 80 times, means it defines the support value, and the together product X and Y together were bought 60 times. So this 60% is defined by the confidence. Okay. So in this way the association rule will be concise in the form of this rule: X tends to Y, 60% is the confidence, and the 75% is the support. Or we can say that for example, this if 60% times the X was bought, so 60% defines the support, and X and Y together were bought 75%, then 75 denotes the confidence. So here we can see that how S and confidence, support and confidence can be correlated and can be assigned as a association rule. Now, rule X and Y, support is defined by the frequency of X and Y in terms of total number of transactions in the data item, and confidence represents the frequency of X and Y brought together with respect to frequency of individual product X. Now, there are various algorithms for defining the association rule mining. So, in association rule mining, basically the goal is to find all the rules which are going to be satisfy the user specified minimum support and minimum confidence value. So, the resulting set of rules are the same irrespective of the algorithm used, whatever the algorithm we are going to use, but the resulting set of rules are the same. Okay. So, the most popular algorithms which are used for association rule minings are a priori, eclat, and frequent pattern growth algorithm, along with various derivations and the hybrids of the three. Just like the extension of a priori is PCY algorithm, Park Chain U algorithm, which is further enhanced or further improved by using multi-chain or multi-hash algorithms. So these are the some algorithms which are going to be used for finding the association rules. So the first one is a priori, and this is the most popular algorithm in association rule mining. So today I am going to discuss this one, a priori algorithm. Now, the a priori algorithm is the most popular algorithm which is used for finding the association rules, or we can say that it is the popular algorithm for association rule mining. So what happens in the a priori algorithms? The frequent item set, basically what is the frequent item set? The definition of frequent item set is what? It is an item set whose support is greater than or equal to the minimum support threshold value. So when I will explain the example of this a priori algorithm, we can see that the minimum support threshold value is already given, or minimum confidence value is already given in the numerical or in the given data set. So, what we have to do? We have to identify the supports of each and every item, and that support will be compared to the minimum threshold value. So, the frequent item sets are those item sets whose support is greater than or equal to the minimum support threshold value. Apart from that particular items, those supports are not, those supports are lower or less than that particular value, minimum support threshold value, then that item sets are not to be considered as a frequent item set. So, the a priori property is a downward closure property, which means that any subset of a frequent item sets are also frequent item sets. Means if a particular item is a frequent item set, then all its subset are also frequent item sets. That is known as the a priori property, which should be followed in our examples or in our particular data sets. So, for example, here example is also given that if ABCD is a frequent item sets, then all its subsets just like ABC, BD, or we can say BC, AC, these all subsets are also frequent item set. Okay. So, the a priori algorithm basically uses the bottom up approaches, and the size of the frequent subsets is going to be gradually increased from 1 item subsets to 2 item subsets, then 3 item subsets, and that process goes on. The group of candidates at each level are tested against the data for minimum support. Means whatever the candidates or whatever the group of items we are going to generate, that each and every combination of item sets are to be tested against the data for minimum support value. This is the flow chart of the a priori algorithm. So, first of all, what we have to do? We have to start the algorithm. Then we have to read each item in a transaction. Now, after that, you have to calculate the support of every item and compare the support with the minimum support value. If the support of that particular item is greater than or equal to the minimum support, then you have to move on to the next step, and if the support of particular that item is less than minimum support, then you have to do removal of that particular item from the transactional data set. So, again, after checking the support value with the minimum support value, what you have to do? If the support is greater than or equal to minimum support, then you have to insert that particular item to the frequent item set, and if that value is less than minimum support, then remove that item from the item sets. Now, the second step is to find the confidence for each and every non-empty subset. Again, you have to perform a check that if the confidence of that particular subset is greater than or equal to minimum confidence, then you have to insert it into the strong rules, and if the confidence is lower than the minimum confidence of that particular subset, then you have to remove that particular subset from the given transactional data. So, you have to perform two checks. First of all, you have to find the support of every item. Then you have to compare that value with the minimum support value. If that is greater than or equal to minimum support, then you have to insert that item to the frequent item sets, or else you have to remove that particular item from the data set. Next, you have to calculate the confidence for each and every non-empty subset, and then again you have to perform a check that confidence is greater than or equal to minimum confidence or not. If yes, then that particular subset will be inserted into the strong rules, and if not, then you have to remove that particular subset. So, this is this is the algorithm which we perform for a priori. Now, here in this given exercise, in this example, we are having a transactional list having 1 to 12 transactions. So, in each and every transaction, we can see different combinations of items. Just like in the first row, we have milk, egg, bread, butter. The second, milk, butter, egg, ketchup, bread, butter, ketchup. So, in this kind of combinations, we are having a transactional list. Okay. Now, the rule again, already I had explained the rule of association rule, that support, the formula of support and the formula of confidence. Now, the other exercises we have that here the dozen sales, here are a dozen sales transactions. So the objective is to use this transaction data to find the affinities between the products, that which product sells together, and the support level is given at 33% and the confidence level will be set to 50%. Okay. So that particular dozen sale transaction is given, 12 transaction means dozen sale transactions are given, and the minimum support is given 33% and the confidence is given 50%. Means at each and every step you have to perform a check with support value 30% and confidence value 50%. Now, what we have to do in a priori, first of all, the transactional list is given here and you have to find the first item sets, that is first frequent. We can also say the one item set, you can also say that first frequent. So what we have to do in this first frequent, we have to identify each and every items in a particular transactional list. So here in the given transactional list, we have 6 items: milk, bread, butter, egg, ketchup and cookies. Okay. So what we have to do in first frequent, you have to identify that how many times milk is appearing in that particular transactional list. So calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times milk is appearing in the transactional list. So the frequency of milk is 9. Similarly, what we have to do? We have to calculate the frequency of each and every item from that given transactional list. Okay. Now the frequency is calculated. Now what we have to do? After calculating the frequency of each and every item, you have to find out the first frequent item sets from the given calculation. So in the question we have given that the support level will be set to at 33%. So the items which are having the frequency 3 means which are having the frequency percentage 30% get to be discarded, because minimum level should be satisfied as 33%. So egg and ketchup will be discarded or will be removed from the first frequent item sets, and the milk, bread, butter and cookies will be considered to calculate for the further frequent item sets. Now what we have to do? We have to calculate now second item sets. So in second item sets, what we have to do? We have to make the combinations of those items which are comes under the frequent first item sets, means milk, bread, butter and cookies. Milk, bread, milk, butter, milk, cookies, bread, butter, butter, cookies, bread, cookies. Means from these number of items, we have to make a combinations of these 4 items. Maximum number of combinations which one can define. You have to define all that combinations, and again you have to check the frequencies of that combinations in the given transaction list. So milk and butter, both the item sets are occurring how many times in a given transactional list, you have to find out this. So milk and bread 1 time, milk and bread second time, milk and bread 4th time, 5th time, milk and bread, total 7 times. So the frequency of milk and bread is 7. Similarly, you have to calculate the combination milk butter frequency, milk cookies frequency and so on. Again, after calculating the frequency, what we have to do? We have to perform the check again, that out of these values, how many frequent second item sets are those item sets whose support is greater than or equal to minimum support, that is 33%. Okay. So again 2 item sets 3 means milk cookies and butter cookies will be discarded from the frequent second item sets. Rest will be considered as a frequent second item set. Now in the next step, what we have to do? We have to identify the frequency of now 3 item sets: milk bread, milk butter, bread cookies. So out of that 2 frequent item sets, we have to find out the 3 item sets, combination of 3 item sets from that particular 2 frequent item sets, and then again calculate the frequency. So what we can see that when we are going to make the combinations of 3 items, then only milk, bread, butter have a frequency that is 6 and rest have the frequencies 1, 2, 3 which are lower than the minimum support value that is 33% value. So what we have to do? We have to consider only one subset, milk, bread, butter having frequency 6. So that subset will be considered as the frequent 3 item sets. After that particular step, what we have to do? We have to perform or we have to calculate the confidence by making the association rule with these combinations milk, bread, butter. So the combinations are milk, bread, butter, milk, bread, bread, butter. These are the non-empty subsets. So how to perform the association rule? So rule 1, the rule 1 can be, we have milk, bread and butter. These 3 frequent item sets are to be considered as the strongly acceptable item sets. So first rule, what we have to, what we can make with these item sets, that milk tends to bread, comma, butter. Okay. The second rule is bread tends to milk, comma, butter. And the third rule will be, the rule 3 will be, the rule 3 can be milk, bread and butter tends to milk, bread. So in this way we can make the association rule with these 3 frequent item sets. Now after making the rules, what we have to calculate? We have to calculate the confidence value. The formula of confidence is frequency of x and y and with respect to frequency of x. So support of milk is 50% and the confidence value is 66.67%. Sorry, the minimum support is given 30% or 33%, which is given in the starting of the question, and minimum confidence value is 60%. So the confidence, the formula, the support formula is frequency of milk with respect to total number of transactions. So frequency of milk is in the frequency of milk, bread, butter is 6. So frequency of milk, bread, butter is 6 divided by total number of transactions, that is 12. Now the confidence, the formula of confidence, as per the formula of confidence formula is support is equal to milk, bread, butter with respect to support of milk. So milk, bread, butter, the support of milk, bread, butter is 6 divided by total number of transaction, and support of milk is 9, which is already calculated in the previous tables. So by this, so with the help of this formula, we can calculate the confidence. So the confidence of this particular rule is 66.67, which is greater than the minimum confidence value, that is 60%. Now calculate the confidence of second rule, that is bread tends to milk, butter. So the confidence of second is 60%, which is also equal to the minimum confidence value 60%. So right now these two rules are considered as a strongly acceptable rules, because the confidence of these two rules are greater than or equal to the minimum confidence value. Now calculate the next more rules. So the rule 3 is butter tends to milk, bread, and the confidence is 60%, which is again 60%, which is again equal to 60 minimum confidence value. So this rule will also be considered as a strongly acceptable rule. Now the rule 4 is milk, bread tends to butter, means the association rules, what we did here, that rule 1, rule 2, now we are going to converge the rules of previously defined methods. Rule 1, rule 2 and rule 3 are now converged into, or we can say that the rules are inversed or reversed in the different orders. Okay. So now the left hand side of that rule, right side of that rule will become the left hand side of this rule, and left hand side will become the right hand side. Okay. So by swapping this RHS with LHS, we create another rule, and now we calculate the confidence. Again we are getting the confidence value 85.7, which is greater than or equal to the minimum confidence value. So that rule will also considered as a strongly acceptable rule. Next is rule 5, milk butter tends to bread and bread butter tends to milk. So we can see that this and this. Again we are getting the percentage which is greater than or equal to the minimum confidence value. So why this happens, that all the association rules, all the rule 6 are having the percentage greater than or equal to the minimum confidence value, that is 60%. Because most of the time we can see in our daily life that the person or the customer who are going to buy the milk or bread, or he or she might also bought a butter, or if he or she is going to buy a milk or bread, then butter. If he is going to buy a milk, then bread or butter, he or she also buy. So that's why all the rules are to be considered as a strongly acceptable rules in terms of the association rule mining. Now some definitions which are associated with the association rule mining are: first one is confidence. The formula is support of, suppose X and Y are the two item sets, then the formula of confidence will be implied by the support X union Y divided by support of X. So confidence generally measures how often each item in Y appears in the transactions that contains item in X also. Means X and Y, both the items are oftenly how many times the items X and Y are brought together, that can be measured by using the confidence. The second one is lift. The lift of the rule is the confidence. The lift of the rule X tends to Y. If we are going to find the lift X tends to Y, then simply what we have to do, it is simply the confidence of the rule which is divided by the expected confidence. Means lift is equal to the confidence X tends to Y divided by support of Y. Okay, means it assumes that the item sets X and Y are independent of each other, and the expected confidence is the confidence which is divided by the frequency of Y, which I had written here also. Okay, so lift simply is the confidence of the rule which is divided by the expected confidence, and assumes that the expected confidence is the confidence which is divided by the frequency of Y. Okay, this is the formula given here. Now what is the support count? So the number of transaction in which X appears. If X is A union B, then it is the number of transactions in which A and B both are present. Means support count is the percentage of the frequency of the occurrence of that particular event in a whole transactional data set. Second is the maximal item set. So the item set is maximal frequent if none of its supersets are frequent. Means maximum item set is those item sets which are having their subsets not frequent. Means if a particular ABC is a maximal item set, we can say ABC is a maximal item set if none of its supersets are frequent. Means if ABCD or ABCDE, if these supersets are not frequent, then ABC will be considered as a maximal item set. Now the second one is closed item set. An item set is a closed if none of its immediate supersets have the same support count same as the item set. Okay, so in closed item set we considered or we point out the immediate supersets. Okay, and in the maximal item sets we are not having that immediate kind of concept. K item sets, item set which contains K items is a K item set. So it can be said that an item set is a frequent if the corresponding support count is greater than the minimum support count, which I had discussed in the examples also. So that are some definitions which are related to association rule, and now a priori algorithm is followed by some of these steps or by calculating supports or confidence. So that's all about today's lecture, and thank you.